Hi everyone, I hope everyone is good. Yeah, so today we'll actually discuss the ML flows, right? Machine learning flow. So, what are the different steps that are involved in creating a machine learning algorithm, right? Yeah, the first step collecting the data. So, this collecting the data can be from various sources. So, yes, if you are working on your problem, so definitely you can take your data from your own computer, right? It can be CSV file, Excel file, or if you're working for any client, you can actually collect the data from the cloud services like Azure, AWS, or whatever, right? So and even if you're working on your day-to-day learning purpose, you can actually download from Kaggle, Analytics Vidya, and so on. So or else any government websites or further analysis, right? So collecting the data from various sources is very very important, right? So definitely you need to, after collecting the data, you need to define the problem. So define the problem in the sense, what are you going to predict, right? So I just shown you some data set just before for the Titanic data. So here the survived is nothing but a dependent column, right? It is dependent on all other columns, right? So I'll just explain the step-by-step procedure from here itself, right? So first step is nothing but collecting the data, then you need to define the problem. So here my problem is to predict whether the passenger has survived in this Titanic disaster or not, right? So my and what type of ML I need to use here? So it is a supervised learning. Why? Because my dependent future is in the form of categorical variable, right? That is 0 and 1. So that means it is a binary classification. So I can actually go ahead and implement a supervised machine learning, right? Yeah, so here in this example I am actually using supervised machine learning, and it is a binary classification problem, right? Yeah, so got it. So you need to define the problem like this, then you need to collect and prepare the data. So definitely this collection and preparation of the data plays a major important step set. So for this Titanic data set, it has various columns here, right? P-class survive, pre-class name, sex, age, sibling, spouse, past, ticket, fare, cabin number. So these are the columns. So we need to see like which are the features that are most important. So there are feature selection techniques and all, right? So definitely, by just a look, we need to understand like what are the missing values we have, how we handle the missing values. So all this comes in uh, you know pre-processing the data itself, right? So that's why this step is also very much important, right? So next step is nothing but the understanding the data or exploring the data, right? Yeah, so understanding the data. So yes, definitely we need to investigate a lot of distributions, correlation, relationship with different futures, right? With this future, like this future and this future and so on. So definitely a lot of charts or a lot of visualization. So that's why we just did, right? So we just learned about different visuals now. So in Seaborn and Plotly as well. So yes, definitely visualization is very very important to analyze or investigate the data, right? So definitely the statistics also comes into the picture when we're doing a lot of exploratory data analysis, cleaning error, right? Yeah, so next step is nothing but future engineering, right? Yeah, future engineering. Okay, so future engineering is nothing but we are actually creating a additional new feature. Okay, example, extracting here name, right? So extracting the name of the passenger, maybe only the first name, right? Something like that, or combining the multiple columns to a single column, something like that. So and definitely we have seen about the encoding, right? So wherever the strings are there, we need to encode into the numerical values. So this kind of encoding, so all this comes in feature engineering technique itself. This male and female, we need to encode to 0 and 1 format, binary format, right? One out encoding format. So this encoding also comes in future engineering techniques. So a lot of things that are discussed in each steps, right? Yeah, so future engineering. So after feature engineering, we need to split the data, right? So divide the data set into the training set and testing set. So what is this training and testing, right? Yeah, training and testing. I'll just explain with a sort of example. So consider in a semester you are giving, there is 6 months for a semester examination, right? I mean 6 months you learn in that particular semester, and maybe after the fifth month or sixth month you will give the examination, right? So most of the time you will actually give the for time for learning, right? So learn training is nothing but it is a kind of learning, right? So and testing is nothing but kind of examination that you're giving, right? So most of the time you will actually dedicate for learning, that is nothing but you train yourself, train, okay, this is a subject, okay, understand that, go in depth, understand, right? Then after that, maybe after your fifth month, for the sixth month you will actually give the exam, right, for the 10-15 days. So that's how the ML also works. So ML most of the time, uh, you need to train the data, right? And little bit of amount you need to test the data. So similarly, more 80% you need to train the data and 20% you need to test the data, or 70% you need to train the data and 30% you need to test the data, or 60% you need to train the data, or 40% you need to test the data, so on so on. Okay, then after all this you need to choose like which model you need to choose. Okay, so I have explained about supervised and unsupervised. So in supervised we have random forest, decision tree, logistic regression, SVM, ensemble, a lot of ensemble methods, everything, right? So which model we use, so that is very very important. Okay, why? Because we feed the training data into some model, so that model learns the pattern in the data related to the data set, right? So that's why training the model is very 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 important. Okay, so after the training definitely we need to evaluate the model. Evaluate means we need to use some testing, or some assessment or testing assessment, where we will get accuracy, precision, recall, and some other relevant metrics. So based on that we can actually test, yes, my model is performing better or not, right, before actually going to actual deploying in protection, right? So yes, definitely we need to tune a lot of hyperparameter tuning, adjust for better performance and all, right? For why? Because to make the final predictions accurate. So definitely we need to train with different model. We need to tune a lot of hyperparameter tunings around. Hyperparameter tuning is nothing but a lot of tunings around. So each algorithm has a lot of hyperparameter tuning that we need to do. Okay, I'll explain in detail when we are learning uh, or implementing any solving the business use cases. Okay, so so it is the steps. Okay, so yes, definitely training the model, evaluate the model, then tuning the hyperparameter tuning and making the predictions, right? So all this comes in after choosing the right model. So definitely we need to evaluate the model, then we need to assess, right? So this model is actually working in my real environment performance or not. So definitely we need to iterate on the future engineering techniques, model choice, and hyperparameter tuning, and like that we can actually deploy the model. If predictions everything is working good, yes, the model meets the desirable criteria, we can actually deploy it in the any cloud platform or wherever, right? So yeah, so definitely that's why all this analysis, data analysis, choosing the right model, right, everything is very 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 important. So last step is nothing but the deploy. Okay, so I'll just open, so steps, right? So collecting the data, data cleaning, doing the future engineering, selecting the right model, which model is better, then evaluate the model, then the model deployment. So these are the stages in the ML. Okay, so you need to understand this, because definitely you might have uh, came across all these stuffs, right? So definitely we will take some example from right from collecting the data till the model deployment. We'll do some use cases so that you will have a better idea, yes, for this particular problem what techniques we need to use. So future engineering, future selection, right, model building, model selection, model deployment, that two model we can actually deploy. Maybe we can actually create some UI or front end application, then we can actually input, right? So based on input, user input, we can actually predict, and we can actually check whether my model is performing better or not, right? So all this we can actually build. Okay, so these are nothing but different steps that are associated uh, in ML, right? So if someone asks, yes, why do we use ML and so, yes, I've explained you in the first video, right? So ML is nothing but it is again the subset of AI, right? So that focuses on algorithm statistics. So definitely ML actually learns the pattern from the data. So yeah, so we have type of ML like supervised learning, unsupervised learning, reinforcement learning, right? Again we have in the supervised we have classification, regression, then unsupervised we have clustering, dimensional reduction techniques, and so on, right? So coming to the workflow of ML, yes, I think you understood, right? Data collection, yes, gathering the data is very, very important, right? For the task which we are going to solve. Then definitely pre-processing, cleaning the data, transforming the data. It's nothing but preparing the data for the analysis. So just remember, most of the time we spend only on this data cleaning part only in industry, 60% of the time, because industry data normally it will be kind of messy, right? So definitely we need to clean the data, we need to do a lot of pre-processing stuffs around. So a lot of steps are there. Okay, so that's why statistics is very, very important in for data cleaning purpose. Next we have future engineering. So future engineering is nothing but selecting the right features, right? Meaningful features in the sense which column is very, very important for our analysis. So there are a lot of techniques that are there for feature selection, right? So future engineering, so creating additional column, right, from our existing column. So that also we can do. Then after that, model selection, right? Choosing the right model. So which model is better? So it is a classification problem or is a regression problem? So how you can identify classification if the dependent feature is a format of categorical 0 1 male female, so such kind of things, right? So then you can actually think, yes, you can go ahead with a classification. How you can find it is a regression when the dependent feature is in the format of numerical continuous variable, right? Consider fare some amount, right? Or consider price. So again, it is a continuous numerical variable. So then you can go ahead that the dependent feature is in format of continuous numerical variable. Then you can go ahead and create a regression. So that's how you choose between regression and classification. So choosing the right model, then training the model, right? Training the model on the training data set. For why we use training to learn the parameter, right? I just told you an example how you learn in the colleges. So most of the time you learn the pattern, right? And you can actually test it. So assess the model performance on the test data set. So, how is the model performing on the test data set? Yeah, if it is performing better, yes, definitely we need to adjust the model performance for the optimal performance and all. Then you can actually deploy it in the real world applications, right? Yeah, so common algorithm that we use, okay, I'll just explain here itself. Okay, so most of the someone asks, okay, what are the common M&M algorithms that we use, right? Yeah, so it's nothing but linear regression. So for the regression purpose, at least you need to know all this, right? Yeah, linear regression, then we have decision tree, right? Then we have random forest, then we have SVM support vector machines, right? Then we have KNN, k nearest neighbor. Next we have we have neural networks also. We have K means clustering, right? For the clustering unsupervised techniques. Yeah. Next we have PCA, principal component analysis. So a lot of things. Okay, so this machine learning has a lot of algorithms, and definitely it varies from domains to domain, the kind of problems you solve. Okay, so using this ML we can actually have the application right from images, speech recognition. Then we can also have the NLP, natural language processing, right? So nowadays we have seen chat GPT and all those. So if you just input a prompt, you will get a response, right? So a lot of NLP process are there. Then recommendation system. So yeah, if you just open a YouTube, you'll get a lot of recommendations that are being viewed, right, based on your interest and all. So just imagine you are watching some thriller movie, right, so we'll getting other thriller movies recommendation based on that. Or Amazon, if you're just purchasing some laptop, so you will be getting all the recommendations with respect to the similar product. Laptop means you will be getting recommendations similar to mouse, keyboard, webcam, right, or such things, right? So such kind of recommendation engines also are part of ML nowadays. So that can comes also applications, right? Then we have application coming to supply chain, healthcare, autonomous vehicles. So lot of domains we can actually use this advancement. And yes, definitely lot of improvement, lot of techniques are happening nowadays, right? So always remember this, lots of sort of development, sort of deep learning techniques are happening. So it's every day is kind of new kind of uh, it's kind of evolving in AI, right? So this about the complete ML architecture. Why do you use ML, right? So uh, what what are the different applications that you use, right? So you need to know all this, right? Yeah. So I think you understood all the process, right? Right from data collecting to model deployment. So just keep in on all these things in mind, which are very important. Okay. So there are a lot of algorithms we have. Okay. Right from data collecting, pre-processing, feature engineering, model selection, training, evaluation. Then we have hyperparameter tuning, deploying it in the real world use cases using UI. So definitely your client or whoever it is, they can actually uh, you know do some sort of use the application that you actually build upon this, right? So yeah, so this is about the ML applications and so on. So yeah, so next we'll be covering about NumPy in detail. Then we will slowly start taking some data set, slowly start building and understanding the mathematical intuition behind each algorithm. And we can solve different business use cases till a model deployment we will be covering in this section, right? Yeah. Okay, let's see in next class, next upcoming class. Okay, thank you.